Hello everyone, welcome to another segment. So in this segment, we are going to learn about deletion operation of binary search tree. So as we said, for any operation that we will do with binary search tree, if the operation modifies the binary search tree, the important thing to consider is that after the modification, the binary search tree should remain the binary search tree. All right. So let's see for the deletion operation. Obviously, when we delete a node from the binary search tree, that will modify the tree. All right. So we have to make sure that after the operation, it should remain all the properties of BST or binary search tree properties. So when we note a delete from a binary search tree, there can be actually three options. All right. So we are trying to delete a node from binary search tree, and there can be a three option we have to consider. So the node we are trying to delete from the binary search tree, it can be a leaf node. All right. So for example, the node we are trying to delete, it can be a leaf node, that our option one. All right. And option two is the node can be a the node can be a parent node, but only with one child. Okay. Say for example, this node, let's say we're trying to delete this node. All right. So let me use a different color. So here, let's say we are trying to delete this node. This is our option one, when the node we are trying to delete is a leaf node. So option two is we are trying to delete a node that is a parent node, but it has only one child. All right. So the third option is that we are trying to delete a node. All right, that has two children. Say, for example, we are trying to delete this node that has two children. All right, so that is our option three. Okay. And for example, this one also, it has two children. So this will be also our option three. So in the first option, we are trying to delete a leaf node, say this one or this one, and we have also another leaf node, this one. So deleting a leaf node is very straightforward. What actually we are going to do, we are going to replace the link to the deleted node by null. So let's see an example. So if the node is a leaf node, all right, and we are trying to delete a leaf node, all right. So to remove the leaf containing the item, we have to actually set the pointer in its parent to null. So what actually we are going to do, the steps are, first we are going to find the node. Let's say we want to delete 70. All right. So first find the node. So this is our node 70. All right. Now, as this is a leaf node, means it doesn't have any children. So that makes this deletion very straightforward and easy. All we have to do, we have to actually delete the node. Okay. So we have to delete 70. All right. But what we have to do, that 70 had a parent which is 60. Okay. 60 is the parent of 70. All right. So now 60, 70 is the right child of 60. Now, after the deletion, the right child of 60 will be null. Okay. So if the node that we are deleting, that if it is a right child, all right, then we are going to say that parent set right will be null. All right. So instead of 70, we are going to assign this value null. So now 60 doesn't have any right child because the right child pointer is pointing to null. Now, if this is a left child, then we are going to set left with null. All right. So deleting a leaf node is straightforward. All we have to do, we have to delete the node. Now, we have to just take care of the pointer of the parent node of the node that we are deleting. So 60 has a parent, 70 has a parent 60. So now the right child of the 60 will point to a null pointer. All right. So let's see another example. Let's say from the same tree, there is another leaf node 42. Okay. So what we have to do if we want to delete 42? So after we delete 42, the tree will look like we're going to just delete 42. All right. Now 45 had the children left child 42. Now instead of 42, 45 will point to null. All right. So the case 2. So we said the case 2 is option 2 is that the node we are trying to delete is not a leaf node. Okay. It has children, but it has only one child. All right. Say for example, in this tree, this node has only one child. Okay. All right. This node has only one child. So then what actually we are going to do? All right. So here, let's see an example. We are trying to delete node 45. So you can see that 45 is a node where it has only one child. It can have only one child, either a left child or right child. All right. So this node can be deleted after its parent adjust a link to bypass the node. Okay. So you can see that the node is 45 and 45 has a parent 40. All right. Now, just think about that. Say after it, if we delete 45, 45 is actually the right child of 40. Okay, so in the right subtree of 40, every node is greater than 40. That we know, right? So what happens when we delete 45? All we have to do actually, we have to just adjust the link that will bypass the node. So what actually we are going to do? We are going to delete this 45 and the value of the 45 will be copied by the value of its children. Children means child, only it has only one child. All right. So if I can delete 45 and what actually we are going to do? We are going to copy the value of 42 here. Okay. All right. And I can then delete the 42. All right. So you can see that what happens here. So here I'm trying to delete 45. 45 has only one child. Okay. And 45 has a parent 40. Now, if the node is a left child, that means the value is greater than its parent. Okay. So what we are going to do, we are going to actually copy this value with its child values. All right. So with 42, and then we are going to delete the child value 42. All right. So that's where the node will be deleted. All we have to do, we have to actually make sure the parent of the node will adjust the link to bypass the node. All right. So let's see another example. Let's see we are going to delete 60. Okay. So we're going to delete 60 here. So 60 has a parent 50. All right. And 60 has only one child, 70. Okay. So as there is only one child, so all we have to do, we are going to actually copy the value of the child 70 to here. Okay. So the value will be now 70. Okay. And then we are going to delete the child node. Okay, so you can see that here instead of 60 the value is now 70 and we have deleted the 70, I mean the child node of the node 60. Okay, so that means actually we have deleted the node 60. Now 50 has the child node which is 70. All right. Now we're going to talk about our third option. So the first option was no child. Second option was we have only one child. So the third option is that when we have two children. Okay, so a node can have actually two children. So for example, this node, and this node, all of this node has two children, and in that case actually it is slightly more complicated. Okay, so the deleted value must be replaced by an existing value that is either one of the following. So we can pick the largest value in the deleted node's left subtree, or we can pick the smallest value in the deleted node's right subtree. So let's see one example. So here, let's we are trying to delete 40. Okay, so you can see that actually when we are going to delete the node 40, okay, so we have to pick a node here. We have to pick a node which by which you can replace this value 40. Okay, so when we are going to replace this value 40, we can actually pick the value from the largest value in the deleted node's left subtree or the smallest value in the deleted node's right subtree. So what we can do here, so this node we are going to delete. All right, so we can pick either the largest node from this left subtree or the smallest node from the right subtree. All right, okay, now let's see what actually we are going to do. We are going to pick the smallest node in the right subtree. Okay, so let's pick the smallest node in the right subtree. Why is that? Because why is that? Because if we do a in order traversal of this tree, okay, if we do in order traversal of this tree, you will find that we need the actually successor value of this node. For example, let's write the in order traversal of this tree. So that is going to look like 30, 40, then we need 44, 42, 45, okay, 50, 60, and 70. Okay, now you can see that actually this node we are trying to delete, then the largest then the next largest node after, I mean the next larger node after this 40 is the 42. And so after 40, the next large node after 40 is 42. And that is what we can find by having the smallest node in the right subtree. Okay, so this 42, we have to pick this node 42 or this node 30. Okay, so we are trying to delete the node 40. We can pick either 42 or node 30. So the node 30 we can find by finding the largest value from the left subtree, largest from left subtree. Okay, or if I want to pick the value 42, okay, then I can find the value by finding the smallest node in the right subtree. Okay, so what I can do actually in the in order traversal, I can pick the next value of this node, or I can pick the previous value of this node. All right, so either the in order successor or the in order predecessor of this node. Okay, so I can pick any one of them. All right, so let's see an example by picking the in order successor or picking the smallest node in the right subtree, which is the 42. Okay, so let's see how it's going to look like, and what actually we are going to do. We are going to copy this value 40 with 42. Okay, then as I am copying this value 40 with 42, that means I have to delete the node 42. Okay, and now here in this example 42 is actually a leaf node. All right, so we are going to follow the rules that we can delete a leaf node. All right, so this tree will look like this. So we have copy this 40 value with 42. All right, and we are going to delete the node 42. So after we delete the node 42, so that's a leaf node in this example. All right, so in that case, the left subtree, we are going to point to a left pointer of this node 45, we're going to point to null pointer. All right, so let's see another example. So let's see a couple of examples. So let's see here, we're going to delete 4. Okay, and in this example, we're going to delete 14, and here we're going to delete 3, 8. All right, so I want you try to do that by yourself, and I'm going to talk about this in the next segment. All right.